Okay, so in this video, I'm going to show you how to visualize distributions for a continuous variable. And the reason why I specify continuous variable is because when we're visualizing a distribution, we want to see, how the values of a particular variable are, kind of fall along the range of that variable. And for continuous variables, there are, many different unique values that an observation can take. And so it's much easier to look at, say, a visual like a histogram or a density plot or something than it is to look at a table that lists how often each individual unique value is found in the data set. And that's why we do this differently when we're looking at continuous variables versus categorical variables. If you have a categorical variable and you're trying to visualize the distribution of that, the best way to do that would be by using a bar graph, which I have in another video. So this is a video for when you've got a continuous variable and you want to look at the distribution of it. So what I have here is I've got Stata already opened, I've got a data set already loaded in, and just for illustrative purposes, let's say that I want to look at this variable, the distribution of this variable. So this is a math assessment score. Our data set is student level, meaning each line represents a different student. And so I want to see the distribution of this particular score, or this particular variable. So to start off with, this is actually pretty easy. There are two ways that we can look at this, two commands that we can use. The first one is if we want to just look at a density plot. And so we'll look at density plots and histograms. One isn't necessarily more correct than another. So I'll just use this command, and then we'll see we've got a plot that's generated right here. And what we see is way over here on the left. So sorry, before I get there. So the blue line here represents how often values of a certain how often a certain value is found within the data set. So, for instance, 0 is near the peak. So most of the observations of this variable are found around 0. That's what this shows. Very few are greater than about 3.5. And then around negative 3.5 or so, there's very few, but then there's a bunch over here at like negative 8. And the reason for this is because negative 8 is actually how missing values are coded. So what this would suggest to us, if you were to see something like this, is, oh, this negative 8, we want to get rid of that. We want to clean our data so that those negative 8s are removed, because that's going to mess up any sort of analyses that we would want to do. And you don't have to do that now, but we could do that if we wanted to. Just quickly. And then if we run this again, we'll get something that looks more sort of normal, meaning that we don't have this odd, kind of peak way over here on the left because of how those missing values were coded. So here we've got something that is, kind of normal-ish maybe, meaning that it's symmetrical, it's got one mode in the middle and kind of slopes away. And so this just, this is the shape of our graph. If you're really interested in comparing the distribution of your variable to a normal distribution, you can just use the normal option. So same command, add a comma, a space, and then the word normal. And then that's going to generate a graph that shows, with the blue line here, shows the distribution of our variable, the actual distribution, and then the red line shows what a normally distributed variable what this distribution would look like if the variable were perfectly normally distributed. And so this is helpful when deciding on whether you might need to, do some cleaning, maybe transform a variable, something like that. For most purposes, I would say the red and the blue lines are pretty close together, and so this is, normal enough for most purposes. So that's how we would create a plot showing the distribution of a continuous variable for, this is the density plot. The other way that we can do that is by using a histogram. And so we do that using hist is our command, or histogram. Both of those will work. Same thing, we put our variable down here. And then something that I recommend, just because it makes the resulting graph much easier to read, is to use the % option. And so what we get here is something that looks very similar to what we just saw, right? Except that this shows everything in bar graph form, whereas the density plot that we just saw is essentially showing us a picture that traces, the sort of the tops of the bar graphs, as it were. In some cases, like in this case, it looks very similar, but in some cases there will be sort of a chunkiness in a histogram, and looking at a density plot just smooths that out a little bit more. The reason why I like using the percent option is because it makes the y-axis a lot more interpretable. So as opposed to the default, where say we don't include that percent option, the shape is actually the same. It's just that when you see density, like what does this mean? Harder to make sense of versus running a histogram like this. So for instance, because this is now labeled as percent, so you can read 6 across here and say, well, 6% of observations have a value associated with this position on the x-axis, which is going to be like negative 0.08 to negative 0.12 or something, somewhere in there. So you can kind of interpret the y-axis more if that's important to you. Also, if you're interested in, just like I showed you with the density plot, if you wanted to compare the distribution for this particular variable to a normal distribution for this variable, you can just use the normal option again. So this is going to show you the same thing. So this takes takes the histogram that we've got and overlays what a normal distribution would look like in this blue line right here. And it does the same thing in that it gives you a chance to see how the distribution of your variable compares to a perfectly normal distribution. And then, so that's all there is to it, to generating graphs that show the distribution of a continuous variable.